Subscribe to AmpCode and ring the notification bell to get the latest content.
Okay, so let's talk about building and training the models with MLLib library. So as you already know, MLLib library of Apache Spark will give you the capability to work with the machine learning algorithms using the Apache Spark application. So you don't have to integrate another application for implementing machine learning in your pipeline. You can simply rely on the MLLib library and take the benefit of the distributed computing of Apache Spark. So basically we have all covered the basics of MLLib library, but here let's focus on how to build and train the models using MLLib library, what will be the steps and how you can approach this solution. So the first thing of running a machine learning pipeline is basically to have a use case. So basically the use case will be nothing but your problem statement of what you want to achieve out of your data pipeline or the machine learning pipeline. Then you will be having the attributes that are important to evaluate your machine learning pipeline, and also what is your end goal and the data set and what you can expect out of it. So basically the first thing is you have to create Apache Spark machine learning model, and to do that you have to just create a notebook by using the pyspark kernel. So you can run your machine learning pipeline in a Jupyter notebook as well as your IDE of your preference. But here the first thing would be you should choose a pyspark kernel, and then you can import all types of required modules for your application. So it totally depends on what type of transformation, what type of process you want to do in your application. So here we have also imported matplotlib so that you can visualize our model and the results of the model afterwards when you run machine learning pipeline on your system. Then we also have other modules, so this date time, date util, it totally depends on what type of transformation or the data manipulation that you're doing in your pyspark code. And here as you can see, we got to import the pipeline as well as the pipeline module from the pyspark.ml. So this pyspark.ml is the most important import in your machine learning pipeline, and also here we have like different features like the R formula, as well as we got the one-hot encoder, string indexer and the vector indexer to get your data into the required format. And also you should import your classification as well as the regression model as per the library from the pyspark.ml and the pyspark.mllib. So this is the first step of importing the types that you require in your application. So the second thing is you have to construct the input data frame. So basically your data could be coming from anywhere. So your data set could be present in the S3 bucket, so you can integrate that with the PySpark, as well as the data could be present in HDFS so that you can directly read it from the HDFS location, and your data could be present in any Parquet file or the flat file. It totally depends on the source of your data. So basically the first thing first, you have to construct the data frame. This is the second step of your machine learning pipeline. Then you got to prepare the data. Prepare means you have to just get only the required attributes from your data set and only the required data. So here as you can see, we got different transformation applied. So here we got a sample taxi df, which is nothing but an input data frame, and here we are just selecting some of the parameters that we required in our machine learning model, and here we are doing all the alias, the date format, as well as applying some filters here. So the filters will be able to help you only get the required rows of the data and only the required columns of your data, so that you can input that in your machine learning model. This is very crucial because you don't want unnecessary data in your machine learning pipelines, because it will hamper the results and as well as the accuracy of the model. So you should really focus on what is your problem statement and what type of data that you really require in your as an input in your machine learning pipeline. So this is the next step. As well as once you prepare the data and apply all the transformation and logic to it, the next thing is you have to create logistic regression model. So here you can use different types of machine learning models that we have already discussed, and we are going to also see that in the hands-on tutorial. So don't worry about it. Here we are just creating logistic regression model so that you will be able to understand what is the flow of creating a machine learning pipeline. So here our final task is to convert the labeled data, because since it's a supervised machine learning, your data should be labeled. and it will take you a lot of time, but that's what it is. You have to have the label data into the format that could be analyzed by the logistic regression. So here in the regression model, the input to your logistic regression algorithm needs to be set to the label or the feature vector pairs, where this feature vector is nothing but a vector of numbers that represents as the input point. So here these steps are nothing but converting the label data into the required format, which can be analyzed through the logistic regression. So this is the next step. And after that, the last thing is you have to train your logistic regression model. So the first task is for training your machine learning model is to split your data into the training set as well as the testing or the validation set. This is very important, and the split between this is also very important. So here you can use the random split operation to able to split that data, so that maybe the bigger data set would be like your training data set, because you will be needing more data in for training purposes and less data into testing or evaluation purposes, because it will improve the accuracy of your machine learning model. So 70-30 split is very good. So basically here we are choosing 0.7, means the 70% of the data for training your machine learning pipeline. So this will be the labeled data which you want to input in your machine learning pipeline, and a 30% data will be evaluated based on the training of the model. So once you train your model, the 30% population will get labeled as per the behavior and the logic of the model. So here, as you can see, 0.7 will be the training factor, training fraction, and the testing fraction will be 1 minus 0.7, which is 0.3. And the seed is 1, 2, 3, 4. So seed, you can tweak it as per the output that you require. And also you can use like the random split operation and input the training fraction and the testing fraction to split your data into the training set and the evaluation or the testing set. This is very important, and then you can start building your machine learning model. So as you can see, this is like a step-by-step approach of how to train a logistic regression model. So here you have to create a new logistic regression object for the model. So you can use the method which is logistic regression to able to create a new object for the model. And you can use the formula for the model as well using the R formula. And also you can just undertake the training as well as create the logistic regression model using the pipeline method. So here we are using the pipeline method, and here we are just passing the trained data df, which is nothing but a 70% of your data which you inputted as a data frame. So here you can also save the model, which is like optional step. And also once you train the data set, then the last step would be the evaluation phase, where you will evaluate your machine learning pipeline on the 30% of the population. So these are nothing but the step of creating the machine learning pipeline, and by passing the input data frame and getting the results to your testing or evaluation data frame. So this is how you can build your machine learning pipelines using Apache Spark and get the benefit of Apache Spark of distributed computing to able to handle big data very easily and also apply complex machine learning operations to it. And we are going to see that in detail in the upcoming hands-on tutorials, so that you will able to understand how we can build it and run our machine learning pipeline on the Jupyter Notebook. So I hope we already set up the Jupyter Notebook. So in the hands-on lecture, we'll see how we can create a machine learning pipeline from scratch. So we'll be having some data set of Airbnb data, and we are going to predict the price of the room for a particular day using the machine learning approach.
So that's it for today. I'll see you in the next lecture.